Okay, so one more time. In this section, you don't have to memorize any of the formulas, any of the trig identities. I will give you a sheet to use on the test, or yeah. All right, so the first of the identities we're going to talk about are these double angle identities. So far, we've just had sine, cosine, tangent of just theta, okay? Now what we have here is sine of 2 theta. So that's like, imagine if you had sine of 60, now you have sine of 120, right? So you take the angle and multiply by 2. Now, the question that we're going to talk about here is there a way, if you just multiply the angle by 2, is there a way to correlate the two of them? Okay, so that's what we're going to do. So we have sine of 2 theta, and we've got one formula for sine, one trig identity for sine of 2 theta. For cosine of 2 theta, if you look on the right hand side, we've got 3 options, and they all 3 of those are they have equal weight. One is not better than the other. The only difference is some problems might just lend themselves to you using one over the other, okay? And then you've got tangent of theta, which is that. Okay. Again, in this chapter, I'm going to ask that you don't use triangles, just identities. And then once we're over this chapter, you can do whatever you want. So here I have sine of theta is 3 over 4, right? So I'm given sine of just theta. And from that I need sine of 2 theta, cosine of 2 theta, tangent of 2 theta. Now, the thing in this problem is we're going to assume we should have been given one more piece of information to zero in on this specific quadrant. So let's just assume we're on quadrant 1. All right, now I need to find sine of 2 theta, cosine of 2 theta, tangent of 2 theta. All right? For those, if you look at the identities, what's sine of 2 theta? It's 2 times sine theta, cosine theta. Do I have all the information for that here? I have sine of theta. Do I have cosine of theta? I don't have cosine of theta. So first I need to find cosine of theta. Okay, so first use identities from 5.1 to find cosine of theta. And what is that identity in 5.1 that helps us find? Right. Sine squared theta plus cosine squared theta equals 1. And what's sine squared theta? 9 over 16 plus cosine squared theta equals 1. So cosine squared theta is 1 minus 9 over 16, which means it's 7 over 16. And cosine of theta would normally be plus or minus the square root of 7 over 16. Right, because we said we're dealing with the first quadrant, let's do root 7 over 4. Okay, now, sine of 2 theta is what we need to find first. So the formula is 2 sine theta cosine theta, right? All right, so this is 2 times, what's sine of theta? 3 over 4. What's cosine of theta? Root 7 over 4. So this is 2 times, well, we can cancel this 2 with this, right? So we get a 2 on the bottom. So what do I get? 3 root 7 over 8. That's sine of 2 theta. No. There isn't that correlation. Sine of theta is sine of 2 theta divided by 2 cosine theta. Like it's this identity. Right? Yeah. Okay. So now what about cosine of 2 theta? You have 3 choices. It's up to you which one you want to use. So which one do you want to use? The first, the second, or the third? The first one? Okay, so if I were doing this, I would have chosen the third one. For me, it's simpler, but let's do the first one. It's really like there is no difference whatsoever. All right, so cosine squared theta is 3 root 7 over 8 squared minus what's sine squared theta? Huh?
Yeah, because it's not cos squared theta is 7 over 16.
Oh my god, I'm so sorry. I don't know what I'm doing. Sorry. Yeah, cosine squared theta was what? 7 over 16. Minus, what was sine squared theta? 9 over 16. So how much is that? Negative 2 over 16, which means cosine of 2 theta. Right. Now, tangent of 2 theta. Okay, so you see that identity over there, 2 tangent theta, 1 minus tangent squared. You're more than free to use that. However, that whole thing with tangent is sine over cosine, that applies. You just have to be careful that if you want tangent of 2 theta, you do the corresponding sine and cosine. So sine of 2 theta over cosine of 2 theta. Okay? So if I want tangent of 2 theta, it's sine of 2 theta over cosine of 2 theta. All right? Now, did I just find sine of 2 theta? 3 root 7 over 8. And cosine of theta, negative 1 over 8. So tangent of 2 theta is what? Negative 3 root 7. So there you have it. That's all 3 of them. Okay? Questions? So with each of these, we're going to do an identity, and then we're going to do a solving equation. Look at this equation. All right, I have an issue with this problem, with this equation. Why do I have an issue? Because I have a mix of things. A mix of what things do I have here? Right, here I have a 2 theta, and here I have a theta. I want to make all of them the same. So, the question now is there any way to get the cosine of 2 theta and to write it as sines and cosines of just a single theta? Yeah, there is. Okay, so now I have 3 options, but which one am I going to pick? The first, the second, or the third? I'm going to pick the second because I also want everything to be in cosine. So here's what you're going to do now, and I'm going to pause this for a minute. What you're going to do is substitute that for cosine 2 theta right here, and then you're going to solve that equation just like we did in section 3. All right? So you have 2 minutes. Go. When we first substitute, right, we get 2 cosine squared theta in the blue, minus 1. We bring in the negative 2, so now we should all be here. Now we need to factor this. All right? This is like factoring 2x squared minus x minus 3. Okay? So how did we factor that? It's 2x and x gives you 2x squared, right? Now I need 2 numbers that give me a negative 3. So the choices there are a 3 and a negative 1, or a negative 3 and a 1. Okay? The deal is when I FOIL, I have to get a negative x for the middle term. So if I do negative what? How would it work? Right, so if I do negative 3 here and positive 1, look at this. 2x minus 3x gives me negative x. So that's the factored form where you have x's not cosines. In terms of cosines, it's 2 cosine theta minus 3 cosine theta plus 1. So now, set each one of these equal to 0. The one on the right gives you cosine theta equals negative 1. The one on the left, cosine theta equals 3 over 2. All right, where is cosine of theta equal to 3 over 2? Nowhere. Why? Because, right, cosine can never be more than 1. So that doesn't work. Where is cosine, which is the x-axis, equal to negative 1? At pi. So that's my answer. Yeah. Now, just like we've seen before, we can get one identity, transform it, and get another identity, right? Like the Pythagorean identities, we can transform them and get the other two friends. Same thing with this. This is one of our identities, right? One of the identities for cosine. Well, guess what? We can solve this. Can we solve this and get sine squared theta? So let's subtract 1. We get cosine 2 theta minus 1 equals negative 2 sine squared theta. All right. Now, can we divide everything by negative 2? Sure. We get negative cosine 2 theta plus 1 all over 2. I'm distributing the negative. And that equals sine squared theta. But I hate these negatives, like free-floating negatives right there. So why don't I rewrite that as 1 minus cosine 2 theta over 2. Right? All I did was some algebra, like add, subtract, da-da-da. What did I get? You know what I got? A whole new identity right there. Okay? So these are your power-reducing identities. Because sometimes in the context of a problem, you don't want your sines and cosines to have any exponents other than 1. All right? So what this does is it takes the exponent of 2 and makes it go away into just exponents of 1. All right? So now, here we have cosecant to the power of 4 theta. And you know what? We're not friendly with exponents today. So we just want to get rid of the exponent. We want to write cosecant of 4 theta, cosecant to the power of 4 theta, in terms of other functions, no exponents though. But we can have multiple angles. So like 2 theta, 4 theta, those are fine, just not exponents. Okay? Now, let's do this. So first and foremost, this is cosecant, right? But I have the identities for sine, cosine, tangent. So what's cosecant most like? Sine. So I say, okay, this is really 1 over sine to the 4 theta. Okay? Well, that's fine. But you know what? None of my identities are with an exponent of 4. They're all squared. Well, can I write something to the 4 as something squared? Can I write this as 1 over sine squared theta squared? Sure, why not? It feels like we're just doing everything. Okay. Now, is there an identity for sine squared theta? Where? Right up here, right? So this is 1 over, it's not really. It's 1 minus cosine 2 theta over 2 squared. So that's a mess. Can't I just flip it? Sure. 2 over 1 minus cosine 2 theta squared. Okay, so I still have a square. Oh my God, what am I going to do now? Well, why don't I multiply in the square? So 2 squared gives me 4. Let's square the bottom, right? What are we going to get if we square the bottom? 1 minus 2 cosine 2 theta plus what? Right, cosine squared 2 theta. But oh my God, what have I done now? I still have that darn square, right? Okay, so that's a mess. So let's see. I have 4 over 1 minus 2 cosine 2 theta plus, I'm fine with that. It's that term that's messing me up. Okay? Well, we're going to apply the identity again. We're going to apply this identity this time, the cosine squared identity. Okay? So let's talk about that identity. Huh? Yeah, everything in section 5 will be given to you in this lovely sheet. Okay? I don't even have these memorized. Nobody really does. Okay. No flashcards. I give you the sheet so that everybody is on the same page. Get it? Okay. Haha. Okay, so now look at what this does. Cosine squared theta, right? It takes theta, and now it's 1 plus cosine 2 theta. So what if this was cosine squared x? What would that be? If this was cosine squared x, that would be cosine 2x. If this was cosine squared table, that would be cosine 2 table. If this was cosine squared 2 theta, that would be cosine 4 theta. Okay? So it takes this angle and doubles it. Okay? So in here then, it's going to be 1 plus cosine 4 theta over 2. Okay, so this identity up here takes the theta and multiplies it by 2. So here I have cosine squared something, right? It's going to take, what's cosine squared anything? It's 1 plus cosine 2 times the angle. So 1 plus cosine 2 times that angle, which is 4 theta. All right? So now, what can we do with this? Okay, we have to do a common denominator on the bottom here. Common denominator, multiply everything by 2, so I get 2 minus 4 cosine 2 theta plus 1 plus cosine 4 theta all over 2. Yes? Now, what can I do here? We reciprocal, right? So we're going to multiply the 4 and the 2 with each other. It's 8 over 2 minus 4 cosine 2 theta. Oh, wait a minute. Can I simplify the 2 and the 1? Yes, we can. Plus cosine 4 theta, if I can write. Now, do I have any exponents other than 1? I'm done. Yeah, that's it. So, you can either tell somebody cosecant to the 4 theta or that. And believe it or not, they mean the same. They're equivalent expressions.
Why would you ever use that big one?
Well, in the context of a problem, right? Yeah.
I'm confused when there's a number before the cosine and then like before the theta. It's like you can't simplify.
You cannot. Okay, so look. Do you remember when you worked with logarithms? If you have 4 log of 2, right?
Yeah.
Can the 4 and the 2 ever interact with each other?
Yeah.
Never.
No,
Never. This is called the argument of the log. So the 2 is the argument of the log. The 4 and the 2 can't interact with each other. It's the same as if I had 4 root 2x. Okay? I can't multiply the 4 and the 2 and make it an 8x. And it's the same as if I have 4 cosine 2 theta. The 4 and the 2 can't interact with each other. All right? One is an argument. All right. So here, we're going to solve this one. What's the problem here? I have cosine, but here I have a sine squared. Well, if only there was an identity. Is there an identity? Sine squared theta. So go ahead. What's sine squared theta? Okay. Well, that's a problem. Let's get rid of that 2 first. Small steps. 1 minus cosine 2 theta plus 2 cosine 2 theta minus 2 cosine theta equals 0. And here, I can simplify those. So I get 1 plus 1 cosine 2 theta. I multiplied the whole thing by 2. Get rid of that 2. Okay, so now I still have issues. I had a negative cosine 2 theta and a positive 2 cosine 2 theta. I combined like terms. So 2 minus 1 is 1 cosine 2 theta.
Oh, so you can.
I just like term. Yeah. Because it's both cosine 2 theta, they're like terms. Okay. Now I still have issues because now I got a 2 theta and a theta. Well, oh my God, if only there was an identity that combined, that turns the 2 theta into a theta. But wait, there is. Because what's cosine 2 theta?
Wait.
Fired.
Cosine, it's 53. Fine, the only you want to be like.
Right.
And then you're just adding another square.
It's okay for the square because we're solving now. Right? So now, the 1 and the minus 1 go away. Now let's see what we've got. 2 cosine square theta minus 2 cosine theta is equal to 0. I can totally get rid of those 2's first because they're bugging me. Well, because now you can divide through by 2. Now, I can take out a cosine, and I get cosine theta minus 1 equals 0. Now, cosine theta equals 0. Cosine theta equals 1. Well, where does cosine theta equal 0 these days? And where does cosine theta equal 1 if that's the x-axis? At 0. Now, this is over all real numbers, so it has to be pi over 2 plus 2n pi, 3 pi over 2 plus 2n pi. If it doesn't specify, that's when you know it's real numbers. Now, this one, 0 plus 2n pi, what is that? It's just 2n pi. Okay? Any other way to write these two? So what is this saying? It's saying pi over 2, 3 pi over 2, that one, that one, that one.
That's pi over 2 plus pi.
Pi over 2 plus n pi. Okay, so look. This one, 0 plus 2n pi, nobody writes it that way because 0 plus anything is that number, right? on the past quiz. I'll I'll talk about those later. But these, so on the test, I definitely want the 2n pi business. Now this, the pi over 2's, if you can condense to n pi, being an honors class, this is you know, our goal. I won't count it as a mistake, but you know, we wanna get you there. We wanna set the standards high for you guys, okay? Because I just believe that we can do this. Okay, now we love our special angles: the 30, the 60, the 90, the 45. We love them. And then you've got angles like 15 degrees. What is 15 degrees? It's nothing, right? It's 45 minus 30, but what else is 15 degrees? It's also half of 30. So here is 15, feeling all lonely and cast out, right? But then it says, hey, so it's really 30 over 2, so it's famous by association, right? So if I have sine of 15, right, I can write that as sine of 30 over 2. And when I do that, 15 now becomes a half angle. It's half of 30, 30 over 2. We call these half angles. And there's a whole other series of identities for those. Okay? So here are the half angles. Now, okay? Now, let's take a look at how the angles look, how the identities look. So it's sine of theta over 2, meaning if I write sine of 30 over 2, in this identity, theta is the full angle. Okay? That means it's 30 degrees. It's that full angle. So remember that. So now, you're out in the middle of nowhere. You don't have your calculator. And you just have to know what sine of 22.5 is. So after like 7 days, because it takes you that long, because now you're hungry. Right. You know, so now you go, oh my God, silly me, 22.5 is just half of 45. I can totally use a half angle identity. And of course you have your sheet of half angle identities in your pocket all the time. So we're going to do this. So this is sine of 45 over 2. Yeah, you never know. And make sure when you do get, you know, deserted on that island, it doesn't get wet in your pocket. So put it in these like waterproof. Yeah, laminated. Okay. All right. So this is sine of 45 over 2. Okay. Okay. So now, important stuff here. So this is plus or minus the square root of 1 minus cosine. What theta are we going to use? 45, the full angle, over 2. Now, listen. Listen. 22.5 is the angle that we're looking for. What quadrant is it in? Right, this is in the first quadrant. That means my answer is going to be the positive one. Okay, so I'm going to take the positive one. All right, so let's simplify that one. So this is the square root of 1 minus, what's cosine of 45? All over 2. So this is the square root of, common denominator, 2 minus root 2 over 2, all over 2. Simplifying, 2 minus root 2 all over 4. Now we separate the roots, right? The square root of the numerator the square root of the denominator. Oh my god, these are my favorite.
Seems like every.
I know, they're like my kids. I can't differentiate between the three of them, and this is just the same. Yeah, maybe I'll do that in my next life. I'll become a math teacher. Shayna? Okay, I can no longer write, but that should be a 2 on the bottom. That's why they're my favorite, because you end up getting roots inside roots.
I'm so excited.
How does that work?
That's what it would be.
Well, it's like when you take your calculator and you do square root of 2, and then you do the square root of 2 again. It totally works.
It's like you've got like the square root of 16, which is 4, and then the square root of 4 is 2.
Right. So if inside a square root, right. So now, now, okay. So let's do this one. You know what I'm going to do here? Rather than writing sine squared of something, can I just do sine of x over 2 squared? Of course I can.
You are the math teacher, so you make the rules.
Right.
That's how it works.
That's true. Now, okay, so listen. Don't get rid of the squares yet. Now I have a half identity. Well, if only there was an identity for the half angle. Well, but there is. So 1 minus cosine theta over 2 squared.
Can you get rid of the square root because it's square?
No, yeah, hang on. So look, there are 2 important pieces of information here. First, I have plus or minus inside and it's being squared. But we know that once we square something, do we really need the plus or minus anymore? No, because it's always positive. So the square not only gets rid of the square root, but also the plus or minus. So now I just have 1 minus cosine theta over 2. 1 plus cosine theta over 2. And man, those 2's totally go away. Right? So now I have 1 minus cosine theta equal to 1 plus cosine theta. Do the 1's go away? So now I have 0 equals how many cosine theta? So where is cosine theta equal to 0? I know you know.
Pi over 2 plus. No, well, never mind.
Negative cosine theta plus cosine theta.
I subtracted cosine theta.
Wait, if it's a straight,
No.
like
No,
a
added cosine
a
theta.
straight bracket, then
Doesn't matter.
it can be equal to in a round bracket.
Yeah. No, this can be equal to.
Can be equal to 0 and cannot be.
Right. Okay.
Wait, what was
Okay, now we have a whole other set called product to sum. We use these when you have cosine of something, sine of something else. Okay? Like here, I have cosine of an angle, cosine of another angle. And it's cosine times cosine. It's a product. We then convert it to a sum. So I have 1, 2, 3, 4 of these. When I have cosine of something else, which one of the 4 am I going to use? Right. I'm going to use number 2 because it says cosine of alpha times cosine of beta. So this now is half of, and this one is just plugging in. Because I have cosine of alpha times cosine of beta. Okay. So it's half of cosine, alpha minus beta. So what do I have here? 6x minus 3x plus cosine, what?
Of 6x
Right.
plus 3x, which is 9x.
So this is half of cosine
Cosine
3x plus cosine 9x. That's it. That's it.
That's the entire thing.
That's the entire thing.
I like these.
love this. This is fun.
So on the homework, listen.
X is a number.
So on the homework, what you need to do is look at the problem and say, okay, is there an identity? And just look at all your identities and, you know, we choose that way. Now we can go backwards. If I have sine of an angle plus sine of another angle, so this is not sine of alpha plus beta, right? That was different. This is, you're adding two sines, sine of x, sine of 5x, let's say. Okay. Right. So of these four, which one are we going to use for this cosine 255 and cosine 195? Number 3? Okay. So it's going to be 2 times cosine of alpha plus beta. So 255 plus 195 over 2 times cosine 255 minus 195 over 2. And you can add those. And you get 2 cosine of 225, which is a special angle, right? And cosine of 30, which is another one of our favorite angles. So 2 times. 225 is like your 45s, but is it positive or negative in that quadrant? Right, so this is negative root 2 over 2. And what's cosine of 30 these days? Right, and 1, 2 cancels with 1, 2, so I have negative root 6 over 2. And now let's just think about this. In your wildest dreams, did you ever think you could just, in 2 seconds, manually, mentally, just figure out cosine of 255 plus cosine of 195?
No, never.
It should be on TV. It's so amazing, right?
People would watch that.
I'm sure they would. So why would I need this? Because if I had an equation like this, where I have sine of an angle minus sine of another angle, well, now I need to use an identity. Which identity can I use for this one? Number 2. So tell me what that gives me then. 2 times what?
2 times
Cosine what?
cosine of 8x plus 2x over 2. No.
Times sine of, which means I have 2 cosine 5x and I have sine 3x equals 0. Almost. Now, the 2 will go away, right? So here I have cosine of 5x equals 0. And sine of 3x equals 0. Now, the 2 goes away because you divide it up. Okay, now this is the part where we have to focus. I have cosine of an angle equal to 0. So now, let's ask, for what angle is the cosine equal to 0? Pi over 2 and 3 pi over 2. So, cosine of x is 0 at pi over 2 and 3 pi over 2. Right? Cosine of x is 0 at pi over 2 and 3 pi over 2. Now, but this is cosine of 5x. Let's see what the difference is. If I graph cosine of x, what's going on here? Look, if I graph cosine of x, more or less that's what it looks like, right? What happens if I graph cosine of 5x? What's the period of cosine of 5x? How do you get period?
It's
2 pi over b. So it's 2 pi over 5. That means, right, in one cycle, how many of these should be able to fit? 5 of them. So basically, this is going to go much quicker. Okay? That means, if for this, if it's 0 at pi over 2, right? The next one is plus 2 pi, right? But for this one, when is the next one? Plus 2 pi over 5. Okay, plus 2 pi over 5. So, let's get back to this. Now, cosine of my angle equals 0. Cosine is 0 when the angle is equal to pi over 2. And when the angle is equal to 3 pi over 2. All right? So what's x equal to? Pi over 10 and 3 pi over 10. Okay? So cosine is 0 when the angle is equal to 0. Now, it's pi over 10 plus 2 pi over 5n. We just saw this identity, right? It's the first one. It's in the first one on this section. Okay, so now we're not going to use the identity. We're going to prove the identity. Because it's like, okay, well, not by us.
well, it's about to be proven by us.
No, right. It is the same thing, Sam, but we're proving it. We're trying to see where did it come from. Is it right? Like, did the book make a mistake? Is cosine 2 theta really equal to that? So look, I can write cosine of 2 theta as cosine of theta plus theta. When you're doing these identities, by the way, draw the line or something, but it has to be completely vertical from top to bottom, okay? This is cosine of alpha plus beta. So which identity is this one?
I thought you just said we can't use variables.
So I write it as cosine of theta plus theta. This is one of the identities from section 4. It's, remember sine, cosine, cosine, sine. This is the second one, cosine, cosine, sine, sine. So this is cosine of theta minus sine of theta, sine of theta. Okay? Which means this is cosine squared theta minus sine squared theta. And now I also know that cosine squared theta plus sine squared theta is equal to 1. That means sine squared theta is 1 minus cosine squared theta. So this is cosine squared theta minus 1 minus cosine squared theta. When I distribute the negative, it's cosine squared theta minus 1 plus cosine squared theta. Combining the two cosine squares, I have 2 cosine squared theta minus 1. That is where the identity comes from. Okay? So that identity on the first page of this section didn't just pop out of thin air. It was somebody thinking to themselves, well, okay, so I have cosine of alpha plus beta. What if I had cosine of theta plus theta? What would that be? Well, it would be that cosine of 2 theta is that identity. So that's where it came from. All right? Now, homework is due next class, and we're going to